Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome dear grade 8 students to our new chapter, the rectangle. Before starting exercises and proving a rectangle, I'm going to make a quick revision about a rectangle, what defines a rectangle. So a rectangle is a quadrilateral that has four sides as you see here, and it has four right vertices as you see here. That's a vertex, that's a vertex, that's a third one, and that's a fourth one. So as all of us know that the sum of vertices in a quadrilateral is 360. If we divide 360 by 4 equally, we are going to get 90 degrees for each one, and thus we say that the four vertices of the rectangle are right. And about the diagonals, we can notice that the diagonals are equal and bisect each other. Notice they are not perpendicular like the square, they are just equal and bisect each other at the same midpoint, so they are not perpendicular. That's to keep it in mind. But in a square, the diagonals are equal, perpendicular, and bisect each other. Now, according to the opposite sides, as you notice, the opposite sides are equal and parallel in pair. So that one is equal to that one and parallel to it. Also, that one is equal to that one. Those are the opposite sides that are equal and parallel. That's about a rectangle. As we know, that's called the length. The longer side is called the length, and the shorter one is called the width. And the area of the rectangle is equal to the length times the width. That's a quick revision for the rectangle. Now let's get started by knowing and reviewing how to prove that a quadrilateral is a rectangle. So to prove that a quadrilateral is a rectangle, we can prove that it has three right angles. Three right angles are enough. You don't need to prove that the four angles are right, because whenever three of the angles minus 90 plus 90 plus 90. So we can say angles, or we can say the vertices. So we can prove three right angles or three right vertices. That's according to the angles. Now, according to the diagonals, the diagonals should be proved equal and bisect each other at the same time. That's according to diagonals. If we are going to use sides, if we need to use sides, we can choose a pair of opposite sides. For example, those sides, I can choose those opposite sides, that one and that one. That's a pair of opposite sides. I can prove them equal and parallel and one right angle. Definitely we always need to prove a right angle or a right vertex. Okay, that's according to a pair of opposite sides. So I can choose either these two or these two. Now also I can choose opposite and that one, but I need to prove them only equal and not equal and parallel and one right angle. So either I choose a pair of opposite sides to prove them equal and parallel plus one right angle or vertex, or I just choose the opposite sides, those together and those together, and prove them equal plus one right angle. Also, I can choose the same opposite sides, these together and these together, and prove them parallel and one right angle. Every time I need to have a right angle. So that's about the ideas to how to prove a rectangle, and let's get started by the first example. Here, as you see, is a circle of center O and diameters MT and HA. So that's a circle of center O and diameter that measures 6 centimeters. So let's remember, what's the radius of that circle? How much is the radius? If the diameter is 6, then the radius is 6 divided by 2, which is 3. So I can notice here that each of the segments OM, OH, OT, and OA are equal to 3 centimeters, and I can put equal signs on these segments because they are radii of the same circle. So it's clear here that to prove that math is a rectangle, or to show that math is a rectangle, that I'm going to use the diagonals. It's very, very clear that I'm going to use the diagonals. So what should the diagonals be? Let's remember the diagonals should be equal, yeah, and bisect each other. Is that true? Is that obtained here? Let's make sure about the diagonals. MT and HA represent diameters of this same circle, then definitely MT and HA measure 6 centimeters, so they are equal. They bisect each other because simply OM is equal to OT and OA is equal to OH. So that's why we say that the diagonals are equal and bisect each other, and thus math is a rectangle because its diagonals MT and HA are equal and bisect each other. That's according to proving a rectangle or a quadrilateral, a rectangle, by using its diagonals. In the coming videos, we are going to talk about proving a rectangle using right angles, using the sides, a pair of opposite sides, or the opposite sides. So we'll meet in the next videos, inshallah.